So the question says, an astronaut rotates at the end of a horizontal test machine whose arm length is 10 meters. So astronaut is basically sitting over here, and she is going to rotate in the test machine whose R, or the radius, is given to be 10 meters. The acceleration she experiences must not exceed 5g, right? So my A max is given to be equal to 5g, and you can take the g as 10. So that's going to be 50 meter per second square. And as we know, when there's a circular motion, c is going to experience an acceleration towards the center, right? So that's A max ACP is going to be ACP max now is going to be 50 meter per second square maximum. We have to determine the maximum number of revolution per minute for the arm, right? So we have to find how many revolution per minute the arm should do, right? So that's sort of a frequency. This is what we have to find, but we have to find that in per minute basis, okay? So let's see how we can do this. So first thing first, this is a constraint where we'll start, right? So the ACP is maximum 50 meter per second square. And we know that R is also given. So we know the ACP is going to be V square by R. That is the first thing we know, right? So from there, we can possibly calculate V square, and the R is 10, right? And ACP max is 50 meter per second square, right? So my V maximum is going to be 50 into 10. That's going to be 500 square root. Okay, so this is the maximum velocity with which, or speed rather, with which the astronaut can actually rotate. But we have to relate this to the frequency, right? So to find the frequency, we have to use the relationship between the velocity and the frequency, and speed and the frequency, and that is going to be equal to 2 pi r f. So that will give us the f max when we put the value of v max over there, right? So what is going to be my f max now? F max is going to be V max, which is root under 500 divided by 2 pi, which is 3.14 into R is going to be 10, right? So now let's try and calculate that using our calculator. So root under 500, okay? So we're going to go root under 500, right? That is 22.36. So 22.36. Then we divide by 2, and then we again divide by 3.14, and then we again divide by 10, and then we'll get the total F max value here, right? After calculation, it will come to 0.35 revolution per second. Yeah, remember that all the units we have used the SI units. The F which we are going to get is going to be 0.35 rev per second. But in the question, they're asking us to calculate per minute. So all we have to do for the per minute, we have to multiply this by 60. Okay, max per minute is going to be 0.35 multiplied by 60, and that is going to be equal to 0.35 multiplied by 60, and that is going to be 21 revolution per minute. That will be our answer. So in this question, basically we use a couple of relationship, right? So the way we thought that the limitation was given regarding the centripetal acceleration, right? And that limitation we related to the velocity, and then from velocity we moved to the frequency, right, using this equation. So this is how we navigate the problem, right? So we define what is given, from where we can start, and how we can find the final answer.